So we can sort of have an extra class TK someday. Now this one. So let's start with questions. I'm going to do questions, and we can start with so we were doing these questions. The first ones, they were kind of simple. I'll just do this one quickly. The question is in front of you. Okay, let's do this one. So, and we had done the first one. So I'm going to do the second one. 6.54 grams of zinc. How many moles is this? 6.54 grams. That's 6.54 divided by 65.4. Moles is mass divided by MR. So what do we get for this? God, that doesn't even have a calculator with them.
.1.
So we're getting 0.1 moles, right? And he says that it reacts with exactly 100 cm cube of 1 mole per dm cube. So how many moles of HCl is this? This is moles is concentration times volume. So concentration is 0.1 and the volume is 100 cm cube. That's going to be divided by 1000, right? So what is sorry, the concentration is 1 mole per dm cube. So what do we get for this? Okay, how many moles is this? That's also 0.1, right? Yeah, what are we getting this? This is 0.1, right?
Yes.
So that is 0.1. So 0.1 reacts with 0.1. Is that true or false? Okay, what's the ratio in the equation? Is it true or false, the second statement? He's saying 0.1 reacts with exactly 0.1. Will it react with 0.1 or not? Saad?
Yes.
Nee, that's not true. Okay, what is the equation stating? It's stating that 1 mole reacts with 2 moles. So 0.1 should react with how much? It should react with 0.2. Right? So it's not going to react with 0.1. It's going to react with 0.2. Saad, clear है बात?
Yes.
ठीक है यार आपका नाम मैं फिर भूल गया. What's your name? Because you haven't written your name.
Rafi.
Rafi. So ठीक है, we're in luck. I've gotten my power back. Achha, so Rafi, is this clear?
Yes, sir.
Achha, last one, 13. Achha, last one states what does the last one state? That 13.08 grams of zinc. How many moles is that? 13.08 divided by what? 65.4. So what are we getting for this?
0.2.
Achha, so we're getting 0.2 moles of zinc, right? So 0.2 moles. It reacts and gives 9.6 dm cube of hydrogen. So will it give 9.6 dm cube of hydrogen? It's 1:1. So how many moles of H2 would there be produced in this case? It's going to be 0.2 moles, right?
Yes, sir.
And
yes.
You can multiply it by 24 dm cube and you'll get, what do you get? You're going to get 4.8 dm cubes. So you're not going to get 9.6 dm cubes. So this statement is also wrong, right? Is that clear? So, yeah.
Yes.
As I'm moving on, as a similar questions, for example, this one. I said, remember, for a moles question, you don't need to know the whole equation. You can figure out the ratio without even knowing the whole equation. For example, if there's a decomposition equation for calcium carbonate, even though you know the whole equation, but if they're saying that carbon dioxide is produced, now without even writing down the whole equation, we don't know what, let's assume we don't know what is produced next to it. We can still figure out the ratio that there's one carbon over here, there's going to be one carbon dioxide that's going to be produced, right? So it's going to be 1:1. Is that idea clear, that to figure out the ratio between two substances, a lot of times you don't need the whole equation? Saad, clear? Rafi, is this clear?
Yes. Yes, sir.
So in this case as well, you've got a reaction saying that what is the maximum amount of TiO2 that will be produced from this thing, FeTiO3. So I don't know what the equation is, but I know that how many TiO2s can I produce from FeTiO3? Like if I've got one FeTiO3, so there's only one TiO2 that can be produced, right? Is that clear?
Yes, sir.
Yes.
So it's 1:1. 19 tons, I'm going to treat it as 19 grams. So can somebody just open a periodic table and tell me how many moles is this?
0.125.
You're getting 0.125 moles, and this would be 0.125 moles as well. And you multiply it by the MR, which is, what is the MR?
Wait a second. Sir, the MR of titanium oxide, right?
Titanium's MR, it's, I don't know if I have, I think I have it here. No, that's not.
Sir, it's 80.
Hmm?
Sir, 80. This one.
It's 88?
Yes, sir.
What is the mass that you're getting?
The MR is 80.
The MR is 80? So you
Yes, sir.
multiply by the moles, what do you get for that?
10.
10.
So you're going to get 10 tons, right? So these other questions are very similar. I did ask you to do them. Did you get stuck on any one of the questions?
Wait a second.
I mean, I'll quickly try and do some of the questions. Actually, remember some of the questions. Maybe you don't know the equation, right? In those questions, I'll just tell you. For example, let's do this one quickly. Magnesium nitrate is decomposing, so you know this equation. What happens when it decomposes? It breaks down into NGO, and it's going to produce 2NO2, and it's going to produce half O2. Right, that's your balanced equation. Now, in this case, he's given you 29.7 grams of this. The MR of this thing would be NO3 twice as 14 plus 16 into 3, that's 48, 62, 124 plus 24, that's 148. So this is around 148. So that's the moles. So the moles of oxygen would be half of that. So can you tell me the value for this? What do we get for this?
0.2.
How much?
0.2.
0.2 moles. And he's asking for the mass. So you multiply it by the MR of oxygen, which is 32, right? So you're going to get what? 32 into 0.2.
Sir, 0.2 mole is magnesium nitrate.
So this one would be 0.1 moles, right?
Yes.
And that's going to be multiplied by 32. So it's going to be 3.2 grams. It's going to be A. Okay, is that clear?
Yes.
So now for these two questions, if you have the worksheet with you, make sure the equation, you're not sure what the equation is because you're going to study it a lot later on, close to organic chemistry. So I'll give you the equation for this reaction. With cold NaOH, it's the equation is this one. It's NaOH and NaCl is produced. I think there's 2 NaOH plus NaCl, O is produced, and water is produced. Now, in this case, what you've got is you've got 0.125 moles of chlorine. They've already given you that. So 0.125 moles, and you can figure out, they're asking you to figure out the mass of this product, the one that contains sodium, oxygen, and chlorine, this one. So this would also be 0.125 moles, right? And all you have to do is multiply by the MR, which is 58.5 plus 16. That's what's the MR for this?
$74.5.
74.5.
It's 23 plus 35.5 plus 16.
I think it's so what's the answer for this?
9.3125.
Because it's going to be A. This other one, just for the sake of question, I'll just write down the equation. It's a similar reaction, except that the equation is slightly different. So there's that's it's 3 Cl2 and 6 NaOH and 5 NaCls plus NaClO3, and plus there's 3 water molecules. Anyway, so that's your equation. And it's a similar question. You got 0.6 moles of this. We'll do all of them. Because remember, repetition. Remember one thing, that you have to develop muscle memory. Do so many questions that things, they just go on auto. Like you see a question, you just solve it. So try and do as many questions as possible. Okay? It's not, if you understand one question, that's not sufficient, because in the paper you're not going to have a lot of time. It has to be muscle memory. You just see a question, you just solve it. You've done it so many times that you just solve it. So you got 0.6 moles of this, and they're asking you to figure out the mass of this product, the one that contains sodium, oxygen, and chlorine. So it's going to be 0.6 divided by 3 into 1. So 0.6 divided by 3. So that's your moles. And you multiply by the MR of that. So that's, what's the MR for this one? Or jaldi calculator. Make sure you develop muscle memory for your calculator. Okay? The reason I'm making you do all these questions is because you'll be running out of time. Everything should happen in auto. Like your fingers should know which buttons to press. So, and make sure you keep one calculator. Just keep one calculator so that you develop a habit of using that. And don't mess things up on your calculator. So, okay, what's the MR for this one?
0.2. Oh, MR. Where is it?
Yeah.
So MR is 106.5 and
what's the final
answer is 21.3.
So it's going to be A, right? As the next one, that's again very similar. It's 5.4 grams of aluminium powder. So that's aluminium. And that's 5.4 grams. How many moles is that? That's divided by 27, right? So 5.4 divided by 27. And what's the value you're getting?
0.2.
0.2, right?
Yes.
So you're getting 0.2 moles. So 10:3, they're asking for the mass of barium oxide. So how many moles would that be? That's going to be 0.2 divided by 10 into 3. So the moles would be 0.2 divided by 10 times 3. Remember, you don't have time for writing the whole ratio stuff. Just remember, if this is 0.2 moles, 0.6. And
0.06.
So you multiply it by the MR. So what's the MR of this thing? That's barium. That's, I think it's 137.
137.3.
So plus barium oxide, that's 16, right? The 153.3, I guess. The 0.06 into 153.3. What do we get?
Answer 9.198.
Okay, so it's C. Okay. So we're done with that. I said now the next one, moles and gas volume, right? So similar question. How do you, and remember this? If it's RTP, then you use 24 dm cube. What's the formula for moles for its volume of gas? And it's going to be divided by 24 dm cube, right? But only at RTP. Remember, there's going to be another formula which is not going to be at RTP, but that's a different formula and that's a different chapter altogether. So you must read this very carefully. Is it at room temperature or is it not at room temperature? In O-levels, it didn't matter. Because in O-levels, it was always at RTP. Like in yahan pe, there's going to be a difference. Things will not be at RTP as well. So this thing only works at RTP. So moles are given, multiply by 24, you find the volume of gas. So 50 grams of sodium azide, and he's asking you to calculate the volume of nitrogen. So sodium azide, find the moles, 50 grams, right? So 50 divided by the MR, which is 23, plus 14 times 3. Quickly, tell me what the answer is. How many moles is this?
0.77.
0.787?
It's coming 0.7692, so 0.77.
So 0.77 or 0.7. That's, as I remember, right now the working doesn't matter. I'm going to take it as 0.7, right? So what are the moles of N2? That's going to be 0.7 divided by 2 multiplied by 3. What do you get? 0.7 divided by 2 multiplied by 3.
1.05.
Okay, also multiply it by 24 dmq, you'll find the volume of gas, right?
25.
I think the closest is this one. Can you round this off? What was this actually? 0.7 kya tha? It was 0.71 or what?
0.7, wait a second. 0.769, so 0.8.
Yeah, it was actually, I mean, you should have taken 3 significant figures. Or at least 2. You get most of the answers. So, anyways, that 27.7 would be the closest one. TK and MCQs, we don't care about the rounding and the errors that are coming in the calculation at the moment. I said this one is easy. It's a combustion, so you can kind of make that up. It's all you have to do in this question is there's 1 mole of an organic compound and it is found to require 2.5 moles of molecular oxygen. Can you try and do this working, by the way? Like every time an organic compound burns in oxygen, what is produced?
Carbon dioxide and water.
It's always going to be carbon dioxide and water. So every time it's going to be the same thing. So try solving this one. Which one requires 2.5 moles? Maybe all 3 of them are correct. So starting with the first one, does it require 2.5 moles or not? The first one. And 2.5 moles is specifically talking about oxygen over here.
So wait 1 second. So I think the first one is 1.
The first one is wrong. So how many oxygens do you need? Well, it's 2 carbon dioxides, right? I said, remember balancing, TK, I told you, balance the easiest first. Don't start with oxygen. Carbon is 2, carbon is 2, right? Hydrogen, that's 6. So yahan pe kya hoga? There's going to be 3 water molecules, right? And now the oxygens, that's 7, right? So how many oxygens should there be? On the
6
left
to 3.
Hmm?
So it should be 6, so it will be 3 here.
There's 7 over here, this side.
Yes, sir, but there's also 1 oxygen at
Yeah,
C2H5.
there's one over here, so you need TK, that's right. So the first one is wrong, right? What
Yes, sir.
about the second one? You need 2.5 oxygens.
Let me balance first. So I think the second one will be 1.5.
1.5. You got 2 carbons, right? So there's going to be 2 carbon dioxides, right? And there's 2 hydrogens, so there's 1 water molecule, right? So how many oxygens do you have? You've got 4 plus 1,
No,
that's
actually, it's 2.5.
5. Right? It is 2.5,
It's
right?
2.5. Yes.
So what about the third one? Third one.
2.5. 2.5.
2.5. So you got 2 carbons, so there should be 2 carbons over here, and there are 4 hydrogens. So there's 2 water molecules, and that's 4. 6 oxygens on the right side. There's 1 already here, so that you need 5. So that's 2.5 O2, right? Okay. Achha, this one. Which mass of gas would occupy a volume of 3 dm cube at RTP, right? He's talking about the 24 dm cube. How many moles is this? How do you find moles? That's volume divided by?
It's 0.125.
So 0.125, right? I said if it's 0.125 moles, which one of these gases is 0.125 moles? The first one, 3.2 divided by the MR of oxygen 16, right? That is definitely not 0.125. N2, that's 5.6 divided by 28. So that's more than 0.125. SO2 is 8 grams divided by the MR, which is 32 plus 16, that's 32, right? How many moles is this?
0.125. 0.125.
Point?
125.
So you get 0.125. So that's the correct option, right? It's going to be C, right? Is that clear?
Yes.
Achha, fair. The next one is. Just hold on 1 second. Achha, next one. Next question. We can leave this. This is more about inorganic and. We can leave that. 1 mole of each of the following compounds is strongly heated. Any gas produced is collected at room temperature and pressure. For which compound is 24 dm? 24 dm cube is 1 mole, right? So basically, he's asking which one would produce 1 mole of gas. So starting with the first one does not decompose, right? It's only nitrates and hydroxides that decompose. How many carbon dioxide would be produced? That's going to be 1, right? So it's going to be 1 mole. How many NO2s would be produced? 2 NO2s. And how many water molecules will be produced? 1 of them, right? So remember decomposition equations. Carbonate would produce a carbon dioxide, nitrates would produce NO2, and they would also produce another gas, which is oxygen. I mean, you can write the full equation. And hydroxides will produce a water molecule. So you got all of these, and so it's the first one that produces 1 mole of carbon dioxide gas. 1 mole of gas would occupy a volume of 24 dm cube. This produces a lot more than 1 mole. This one doesn't even produce a gas at RTP. This is not a gas at RTP. Is that clear? This question?
Yes.
Yes, sir.
Darling. I said now we're gonna move towards another. Let me open the board once again. I said now we're gonna move towards another type of a type of question which is similar. Obviously, we know the basics now, and in this question, what happens is that, and let's pick this question. I'm going to do this on the board. Hold on a second. And let me open the board link. So it gets open now. So this next type of question, again, it's related to gases, and so these were all the basics. Now, So here's the question. So for gases, remember this, and I'll give you a brief intro for this one. For gases only, and you get these types of questions. Now you've got two options for these questions. You can either do them the long way, or there's a simple way of doing these questions. One is that, remember, for gases, mole ratio and volume ratio is exactly the same. So mole ratio and volume ratio is exactly the same, but only for gases. Like if I have a reaction in which N2 gas reacts with CH2, and it ends up producing 2 NH3 gas molecules, right? So this gets produced. Now, if I say 1 mole of gas reacts with 3 moles of H2 gas, right? That means 24 dm cube reacts with how much? 72 dm cube. Is that clear?
Yes, sir.
Yes.
So what is the mole ratio? That's 1:3. What is the volume ratio? That's also 1:3. Although it's a different quantity, but the ratio is exactly the same. Is that clear?
Yes.
Yes.
And similarly, if I have 0.5 moles of N2, that means I've got 12 dm cube, right? Now 0.5 moles will, according to the ratio, react with 1.5 moles. 1.5 moles would be 36 dm cube. So the ratio is still intact. It's 1:3, right? So the point is, when you're dealing with gases, you don't really need to find out moles. If I tell you that there's 1000 cm cube of N2 that is reacting, right? And if they ask you to figure out the volume of H2, I don't need to find out moles. I know that 1000 one reacts with 3, so 1000 would react with 3000. I don't need to do any calculation whatsoever. Is that clear?
Yes.
Okay, so just remember that for gases, if you're comparing gases, no need to find moles. Mole ratio and volume ratio is going to be exactly the same. And if I have got 1000 cm cube of N2, how much ammonia would be produced? Like it's 1:2. So 1000 will produce how much?
2000.
Okay, so it's going to produce 2000. Okay, so the point is, no calculations are needed. Although you can follow the old path, you can find the moles and compare it, and you can do all the stuff. But over here, that would just be you're just increasing your own work. You don't need to do that. So no calculations are needed. So the following questions, the ones that these ones, all of them are gases. There's a spray and it burns as follows, right? And it's being cooled to room temperature. So the only thing that's not a gas, remember, this does not apply to gas. It only applies to gases. So water is not a gas. So in this question, there's 10 cm cube of methane thiol, right? So can you tell me how much oxygen would be required to burn it?
30.
Okay, so it's going to be, this is going to be 30, right? And how much CO2 and SO2 would be produced?
20.
Okay, combined, that's going to be 20, 10 of this and 10 of this, right?
Yes, sir. So answer is C.
Yes.
So what he's asking for is, if 10 cm cube of methane thiol is exploded in 60 cm cube of oxygen, what would be the final volume of the resultant mixture of gases? So the products that are going to be produced are how much?
Product is 20 and the rest of the unreacted is 30.
Okay. Plus there is unreacted oxygen as well, because he's using 60 cm cube. The reaction only requires 30. So only 30 will react, 30 will remain unreacted. So there's going to be 30 cm cube. Sadi, clear? Is this clear?
Yes.
So the answer would be 50. Okay. So now in these questions, just remember, don't go about finding moles. You don't need to find moles. Although you'll get the answer that way as well, but that's going to be too time consuming. So there's another question. We'll do similar questions like these. So you got this question. 10 cm cube of carbon disulfide was burned in 50 cm cube. So 10, first thing, 10 will burn in how much? How much would be required?
30.
30. And how much CO2 would be produced? 10 and 20 of this.
20.
So the first thing, what is the final mixture of gases? That's 30 is the products that are produced. That's how much oxygen is unreacted. Out of the 50, 30 is reacting, right?
20 is unreacted.
So the final mixture is the 20 unreacted. It involves the 20 unreacted gases as well. So the products you have is CO2 and SO2. And you've got unreacted oxygen as well. Now, so the volume of gas after burning, that's 50, right? Now, after that, volume of gas after adding NaOH. Which of these gases do you think will get absorbed in an alkali? Which one of these gases are acidic?
Carbon dioxide and sulfur dioxide.
Okay, so these gases are acidic because they're going to get absorbed by. So when you pass it through NaOH, these gases will get absorbed. So the remaining volume will be just 20. Is that clear?
Yes, sir.
Because out of the 50, okay. Ahmed, clear?
Yes, sir.
I said this one, try doing this one as well. 10 cm of methane and 10 cm of ethane is sparked. And what is the volume of gas that is absorbed by the alkali? So there's methane and there's ethane. Methane is CH4. Ethane is C2H6. They're both going to react with oxygen and they're going to produce carbon dioxide and H2O. This one would do exactly the same, carbon dioxide and H2O. And you can balance it to yahan pe 2, 2, and this would be 2 and 3, and that's 4 plus 3, 7. So that's going to be 7 by 2, right? Now there's 10 cm of this and 10 cm of this. Which one out of these gases is going to be absorbed by the alkali? Like when it's burned in oxygen, which of these gases will get absorbed by the alkali? Which one is acidic?
Sir, CO2.
Okay, CO2 is acidic. So the first reaction will produce how much? 10 cm cube. And the second reaction will produce how much? That's going to be 20 cm cube. So total CO2 that's being produced is 30 cm cube. And that's so the gas that is absorbed by the alkali is going to be 30 cm cube. As for this, remember, make a small short note over here. Non-metal oxides are usually acidic. Nitrogen oxide is acidic. I mean, the common ones. Sulfur oxides are acidic. Carbon oxide is acidic. Carbon dioxide. I mean, these are the three common ones. They're all acidic. Okay. So we've got so you've got I mean, this is the only page. We're up till page 11 now. So try doing page 11 now. We didn't do page 11, so that's your assignment. Okay. Send the answers on WhatsApp then. Okay. I said make sure you're solving all these questions, because at the end of the day I'll ask for the whole assignment. Like, we'll complete this in class, but at the end of the day we're done with this specific topic about gases, and then we can move on to the next subtopic. Okay, we'll do those questions as well. So the problem to me is, does anyone face any difficulty in any of the questions?
No, sir. Sir, can you send the recording afterwards so I can make everything proper?
Yeah, I'll try and send the recording. Okay.
Okay, sir.
Okay, take care.
Allah Hafiz, sir.
Allah.